Hi all, welcome back to Physics Login. In the last class we have studied about electric charges, right? In the electric charge session we have studied the definition of charge, properties of charge, the charging methods, conservation and quantization of charges. All those topics we have studied in detail, right? In today's class we are going to study Coulomb's law. Coulomb's law is an experimental law which deals with the interaction between electric charges. You have studied in the lower grade that if two positive charges, two similar charges kept at a distance, what happened? They will repel each other, right? Similarly, two negative charges, that is, like charges repel each other. If you kept unlike charges, that is opposite charges, what happened? They will attract each other. This you have studied in lower grade, right? So these charges will attract or repel with a force. Coulomb's law gives the measure of that force. Okay, Coulomb states that the force of attraction, suppose two charges, suppose plus Q and again plus or minus plus Q, then what will be the type of nature of the force? This is repulsive, right? So this force is kept at a distance. This distance is R. Okay, Q1, Q2. So this charge will repel this in this direction. Suppose this is F. Force on first charge due to 2. Second charge, right? Force on first charge due to second charge. So F1, 2. Okay, in this direction. Similarly, the first charge will repel the second also in this direction, right? So force on second charge due to 1. So this is the representation of force between two charges, right? These two charges should be point charges. So Coulomb states that the force of attraction or repulsion between any 2 point charges is directly proportional to, suppose F21 is directly proportional to product of the magnitude of the charges. Product of the magnitude of the charges. You don't need to put the sign of it. Put the magnitude of the charges and also inversely proportional to the square of the distance between their centers. This is the law. Clear? So one more time I will tell you. You can notice Coulomb states that the force of attraction or repulsion between 2 point charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between their centers. Clear? So what we can do is we can combine these two statements. So it will become F proportional to mod of Q1 mod of Q2 divided by R square, correct? We can write this as an equation by introducing a constant to it, right? F equals, this we are writing for 2-1, right? 2-1, 2-1. F21 is equal to a constant K into Q1 mod Q2 divided by R square. So this is the equation for Coulomb's law. Okay. Now we can examine the constant. This constant K is called Coulomb's constant. Or electrostatic constant. Coulomb's constant or electrostatic constant. And this constant is not a universal constant, okay? It will change. When it will change? It changes depending on the medium between these two charges. What is the medium between these two charges? Okay? So, and there is a property of that medium, permittivity. We will study that in detail in another video. For now, it depends on the property of the medium between these two charges. Clear? So K depends on, so K is equal to, actually K value is equal to, for air or vacuum, we are considering only air or vacuum, 1 by 4 pi, this symbol is epsilon naught. Epsilon naught is for air or vacuum, and this term is permittivity of free space or air. Okay, both we have considered this as permittivity epsilon naught for air and vacuum. So this value of this for air is epsilon naught is 8.85 into 10 raised to minus 12 Coulomb square Newton meter square. Coulomb square per Newton meter square. This is the unit. So when you substitute this value in epsilon naught, the K, the electrostatic constant for air or vacuum, is equal to 9 into 10 raised to 9. You should by heart these values. K is equal to 9 into 10 raised to 9 and epsilon naught is equal to 8.85 into 10 raised to minus 12 Coulomb square per Newton meter square. Okay, clear? So this value, this K value depends on the medium between these two charges. If it is air, we can use these values. Okay, air or vacuum. Clear? Now I'll explain one more time what is Coulomb's law. Coulomb's law states that the force of attraction or repulsion between any 2 point charges is directly proportional to the product of the magnitude of the charge and inversely proportional to the square of the distance between their centers. This is the statement, and you can write this equation: F is equal to K Q1 Q2 by R square. K Q1 Q2 by R square. What is this K? This K is the Coulomb's constant or electrostatic constant. So this value is not a universal constant. It will change. When it will change, it depends on the value, it depends on the medium between these two charges. Okay. For air and vacuum, the value is 1 by 4 pi epsilon naught. What is epsilon naught? Epsilon naught is the permittivity of free space or air. Permittivity of free space or air. For air or vacuum, you can use epsilon naught value 8.85 into 10 raised to minus 12 Coulomb square per Newton meter square. Correct? Then for value, when you substitute this value in this equation, you will get, you can use directly K is equal to 9 into 10 raised to 9 for air or vacuum. If the medium between those two charges given in the question is air or vacuum, you can use these values. Otherwise, we have to find the permittivity of that particular medium. If two charges are kept in a liquid of a different permittivity, we have to find the permittivity, or that permittivity value may be given in the question. So such questions and that concept we will study, we will discuss in another video. Okay. Now this is Coulomb's law. Note, you can note this, take a screenshot or make a note of it. Okay. Then look at this equation. K Q1 Q2 by R square. Force, electrostatic force. This force is electrostatic force, right? In 11th grade in gravitation, you have studied the gravitational force. What was that equation? That equation was G m1 m2 by R square, right? Two similar equations. So we will compare what are the similarities and difference between these two forces. Comparison of electrostatic force and gravitational force. Next is comparison of electrostatic force and gravitational force. Okay, you don't need to by heart this, you just compare it with these two equations. Write these two equations. What is Fe? I will take it as electrostatic force. Okay, electrostatic force is equal to, what is the equation? K Q1 Q2 by R square. Correct? Fg, gravitational force, right, equal to G m1 m2 by R square. Correct? these two equations. First, just observe this. This is charge, right? Charge, and this is mass. So from that we can find out that first difference. Okay, compare this, similarities and difference, we can write both. Charge can be attractive or repulsive, right? But what about mass? Mass can only be attractive, right? So first one is, I'll write like this. Okay, can be attractive or repulsive. Correct? This can only be force of gravitational force can only be attractive. Correct? Next, look at this, r square and r square. So inversely proportional to square of the distance between their centers. So that is inverse square law. So both follow inverse square law. Both follow inverse square law. Then inverse square law means if you draw the graph of force and distance, when the distance increases, what happened? Inversely proportional. The force of attraction reduces, right? But inversely proportional to the square. So exponentially it is decreasing. So if the distance is less, the maximum value of force, right? When the distance increases, it decreases exponentially. Here also the same thing, same graph for F and R, exponentially, right? F inversely proportional to R square. F inversely proportional to R square. This is FE, this is FG. That is inverse square law. Correct? You will get question for your board exam like this. If what happens, what will be the force when the distance between the charge is doubled? Double means increasing. Definitely the answer should be the force should decrease, right? If it is doubled means square, you just take the square. Double means 4 times. It will decrease by 4 times, right? Like that you can do such questions. Next we can compare these value constants, right? K and G. This is universal constant. This is depends on medium, right? So this force of attraction is constant. It does not depend upon any medium. This depends on the medium. So next is electrostatic force depends on the medium between charges. In gravitational force, Fg does not depend on medium between masses. Correct? And one more thing you can write using this value. What is the value of K? K is equal to 9 into 10 raised to 9, right? What is the value of G here? G 6.67 into 10 raised to minus 11. Look at the magnitude of these two constants. Magnitude is having very large difference, right? This is very small quantity, 10 of the order of 10 raised to minus 11. This is a very large quantity of the order of 10 raised to 9. So this is a large, strong force. So we can write it as Fa is strong force and this is a weak force. So you can compare electrostatic force and the gravitational force like this. We don't need to by heart these things, okay? Remember this equation and compare both the forces from that equation itself, okay? Now next we will do some numerical related to for the application of Coulomb's law. You can note this, okay? Okay. First question. First question, two particles, okay? Two particles, A and B, having same charge, Q. Charge equal to Q. And same mass. Mass equal to M, okay? Two charges A and B, same charge, same mass, okay? Is mutually in equilibrium with the gravitational and electrostatic forces. These two particles in equilibrium with the electrostatic force and gravitational force. Okay, this is the question. Find the order of the ratio Q by M. You need to find the order of the ratio Q by M. One more time I will explain the question. Two particles having same mass and same charge, kept at a distance, okay? This separation, kept at a distance. Now, these two charges are in equilibrium, mutual equilibrium with the electrostatic force and the gravitational force. You have to find the order of the ratio of Q by M, that is charge to mass in Coulomb per kg, okay? Coulomb per kg. Then options I can give you: A, 10 raised to minus 5, 10 raised to minus 10, 10 raised to minus 15, 10 raised to minus 20. Okay, do this question. Do this question. Pause the video and do this question and check the answer. Now I will solve this question solution. What is given in this question? Q. The charge is Q, mass is M. For both it is same, right? Now equilibrium with Fe and Fg. Equilibrium means both the forces should be equal, right? Equal and opposite. So Fe should be equal to Fg, correct? So what is the formula for Fe, electrostatic force? K, Q1, Q2. Here both the charges is having Q, right? So Q square, correct? Divided by R square, correct? Q1, Q2 by R square. Equal to Fg, gravitational force. Gravitational force equation goes G, M1, M2. What is the mass? M and M, right? So it will be M square divided by R square, correct? This is our condition. Then R square and R square, separation is same, right? Separated by a particular distance. So this value you can cancel. And what is your required? Then Q by M value you have to find out. So Q by M, okay? Bring the M square into this side. So this will become Q square by M square equal to G by K, correct? G by K. This M square is coming down and K is coming down, so equation will become this, right? So we want Q by M. Q by M. So Q by M, the whole square is equal to, what is the value of G? 6.67 into 10 raised to minus 11, right? Divided by, what is K? 9.9 into 10 raised to 9, right? So this you can write it as 6.67 divided by 9 into this 10 raised to 9 will go on to the numerator and become 10 raised to minus 9. 10 raised to minus 9 plus 10 raised to minus 11, it is 10 raised to minus 20, right? We need only the order, okay? Order, we have to find out the power of the 10 raised to what power? That is the question. This is our required. So we don't need to do this thing. So this is square, right? Q by M is equal to, this is root of, root you can write it as 6.67 by 9 raised to 1 by 2, correct? Root into 10 minus 20, 1 by 2, correct? 10 by, so 1 by 2 into 20, it will become approximately equal to, we need only this value, you don't need to calculate this approximate value, because these choices are, the options are 10 raised to 5, 10 raised to 10, like that. So It will be approximately equal to 10 raised to minus 10. So this will be the order, and the answer is 10 raised to minus 10B. Okay? Not this. Now the second question. Second question is, under the action of a given Coulombian force. Coulombian force means electrostatic force, okay? Under the action of a given force, let it be F, okay? Under the action of a given force, the acceleration of an electron of an electron, let it be AE, okay, is 2.5 into 10 raised to 22 meter per second, okay? What will be the acceleration of a proton, AP, at the same, under the action of same force? So, under the action of a Coulombian force, electrostatic force, FE, the acceleration of an electron A is 2.5 into 10 raised to 22 meter per second square, okay? Then, what will be the acceleration of a proton? I'll give you the options. Option A, 1.6 into 10 raised to minus 19 meter per second square. B, 1.5 into 10 raised to 19 meter per second square. C, 9.1 into 10 raised to 27 meter per second square. D, 1.6 into 10 raised to 27 meter per second square. These are the options. Okay, try this question. Ready? Done? Okay, I'll give you the solution. So acceleration of electron is equal to force divided by mass of electron, correct? F is equal to ma, correct? So acceleration of proton is equal to force divided by mp, mass of proton, correct? Since the same force is acting on both the particles, so F and F will, you will take the ratio, F and F will get cancelled, right? So AP, divide this equation with this, second, first. So AP by AE is equal to AP 1 by MP, so MP ME, correct? ME. So therefore acceleration of proton will be is equal to acceleration of electron into mass of electron divided by mass of proton, correct? Is that correct? Now you can substitute the values. Okay, now you can substitute the values. So that will be equal to acceleration of electron is given in the question 2.5 into 10 to the power 22 into mass of electron. What is the mass of electron? What is mass of electron? 9.1 into 10 raised to minus 31 kg, right? Then divided by mass of proton 1.6 into 10 raised to minus 27. So we can solve this approximately, okay? This you can take it as 9, this is 1.5. 1.9 divided by 1.5 is 2, 4, 6, right? 6. 6 into 2.5, 2.5, 15, right? 15 into 10 to the power, this power, 10, when it comes to numerator, what happened? 10 raised to 10 to the power 27 plus 27. 27, 22 minus 31. 10 raised to 8, right? 18. So that will be equal to 1.5 into 10 to the power 19, correct? So the answer will be this. B. Option B is the correct answer. Copy this. Done? Done? Okay. One more question, the last question of today's class. The last question of today's class. Question number 3. Two pith balls of same charge is suspended using two strings as shown in the figure. Okay, the equilibrium separation between these two balls is R. Okay, mass of the ball is M. Okay, and this distance also given in the question, that is y. The question is, when this arrangement is rigidly fixed like this at y by 2, what will be the equilibrium separation? That is your question. So two pith balls means the charged balls. Charged balls are hanged using a string like this. This is shown in the figure. And the equilibrium separation, that is this separation, is given as R. Okay, in the question. And the question is, what will be the equilibrium separation if the same string is rigidly fixed at y by 2? This distance is y by 2 now. What will be the equilibrium separation? That will be the question. Options: A, R by root 3, B, R by 2 root 3, C, R by cube root 3, D, R by cube root 2. Cube root. So these are the questions, options. These are the options. Try this question. This is a very good question. So try this. Take 5 minutes. Do until you get the correct answer. Okay. Okay. Now done. I will do the solution. So this is an equilibrium state, right? Equilibrium state means net force acting on this ball will be equal to 0 here, and here the ball will be, the net force acting on this balls will be 0, right? So what are the force acting on this ball? mg, right? Here downward. In this direction, this is separate repulsion, right? So in this direction, what is electrostatic force? And one force is acting in this direction, that is tension. So similarly here also, a force mg is acting downward, repulsive force, electrostatic force Fe, and a tension is acting on the string. So look at it. Suppose let this angle be theta, then this angle will also be theta, right? Become theta. These two angles, parallel lines. If this is theta, this will also be theta, right? Like this. If this is theta, this angle also be theta. We can resolve this tension to vertical and horizontal component, right? What will be the vertical component of this? Adjacent side. Adjacent side means t cos theta. Horizontal, opposite. So it will be t sin theta. Correct or not? Resolved easily. Then look at this. T sin theta component is balanced by electrostatic force, and T cos theta component is balanced by weight, right? Weight of the ball. You can write as two equation. T sin theta is equal to Fe, correct? Electrostatic. T cos theta is equal to T cos theta is equal to mg. So you will get two equations, 1 and 2. So look at this. You can divide this equation. T and T will get cancelled. Sin theta by cos theta is equal to tan theta is equal to Fe by mg. Any doubt up to here? They given in the question the equilibrium separation. So these particles are in equilibrium. What is the equilibrium condition? Net force should be equal to 0. So resolve all forces, all vertical forces and horizontal forces should be equal to 0. So T cos theta is balanced by mg. So vertically it is 0. T sin theta is balanced by Fe. So vertically it is 0. So this is the two equation. From this equation you will get tan theta. Tan theta is equal to Fe by mg. One more thing you can do is, look at this triangle. From this triangle you can find tan theta, right? So tan theta again, opposite side by adjacent side, right? What is this opposite side distance? This is r, this will be r by 2, correct? So r by 2 divided by what is this distance adjacent side is y. Look at that. Tan theta is equal to r by 2y, tan theta is equal to Fe by mg. So you will get a relation between y and r, okay? You can equate both these things. Fe by mg equal r by 2y. Correct? What is the electrostatic force between these two charge balls? That will be K Q1 Q2 by r square. Correct? So this you can write it as K Q square, right? Both the charges are same, by r square into mg equal r by 2y. You have to find out a relation between r and y because this is the changing, right? Y is changing and r is changing. So if you find a relation between y and r, you can find out the new, let it be r dash, new equilibrium separation, right? New equilibrium separation you can find out using this equation. Look at this. Make y subjective. Y equals, this r square will go this side, right? So it will become r cube. Look at this. K q square constant, right? mg constant, right? Two constant. So whole term will go there and it will become a constant. So y is equal to k into r cube, correct? So you can write that y equals k into r cube. So y proportional to r cube. This is your relation, right? From this diagram. Now you can go to the second diagram. This is your question. So what is y here? It is y by 2. Y by 2 equals k r dash cube, correct? R dash cube. Y by 2 is equal to k r dash cube. So you can divide this equation. That will be first, this is second, 2 by 1. 2 by 1. Y by 2 divided by y, right? Equal k r dash cube divided by k r cube, correct? K and k will get cancelled. Y and y will get cancelled. Make r dash subjective because we required r dash value. So r dash cube is equal to, r cube will go this side, r cube divided by 2, correct or not? So we required r dash value, that is the equivalent separation, right? Equilibrium separation. So r dash is equal to cube root of r cube by 2. This will be equal to r divided by cube root of 2. So this is your answer, r divided by cube root of 2, d. Answer D. Okay, with this numerical we will conclude today's class. In the next class we will study superposition principle and equilibrium of charges questions. Two types of numericals left in Coulomb's law that we will do in the next class. Before that, I will upload a small video of vector form of Coulomb's law. Okay, we didn't do that. That is very important topic for your board exam. So That will be the next video, Coulomb's law in vector form. Okay, till then, study well, take care, bye.